Hi, this is Jason, and welcome back to the lecture. In the previous video, I talked about the importance of infrastructure as code and how we can build infrastructure in a programmatic way, just like we build software applications. This has the benefits of allowing us to build infrastructure in a repeatable and testable manner. The way that we build infrastructure using code in AWS is using a service called CloudFormation. So CloudFormation is an infrastructure definition tool which allows us to use infrastructure as code techniques to create almost any sort of resource that we need in AWS. In fact, every sort of resource that you might build via the web console is also buildable and deployable using CloudFormation. Several AWS services like Elastic Beanstalk actually use CloudFormation behind the scenes to provision infrastructure that is needed. Now, when we build things using CloudFormation, we always start with a template. It's a text-based template that is written either in JSON or YAML format. And this template describes all of the different resources and the configuration of the resources that we want to deploy into our AWS account. The cool thing about being able to describe our resource configuration in something like a template is that it promotes good infrastructure as code practices. We can store that template in a version control system like Git. We can use it in our infrastructure delivery pipelines in order to test out environments. For example, I can use a CloudFormation template to quickly spin up a development environment where it might perform a series of tests before deploying infrastructure changes to a staging or production environment. And the template is something I can share with other people in the organization. I can create a template that defines a set of infrastructure that's needed to support a service that I'm building, and then I can share that template with others in the organization, and other people then are able to spin up the exact same set of infrastructure that I have defined in my template. Now, when you use a template to deploy a set of resources using CloudFormation into your AWS account, what CloudFormation is creating is something called a stack. A stack just simply represents a set of AWS resources that have been deployed using a CloudFormation template. How does this CloudFormation process work then? Well, we start by creating a CloudFormation template using a code editor. I like to use VS Code, but you can use whatever sort of code editor you would like to create your YAML file. Then you save that template locally, or you can save it into, copy it up into an S3 bucket. But you have to have a template file that's stored either in disk or in S3. And then once you have that template file, you can go into the AWS Web Console, or you could even use the AWS CLI command, and you can create a stack by specifying that template file and optionally providing any sort of input parameters that are required. And we'll talk about parameters here later on in the video. CloudFormation then will provision all of the different resources that are defined in that stack, and you will see an event log as it progressively creates each one of the resources in your template. And when it's finished, it will report back and let you know that the template creation is complete, which signifies that all of the resources that you had described in the template are now provisioned in your AWS account. Well, what does this template look like? Let's spend, the next 20 to 30 minutes walking through the various components that you'll find in a CloudFormation template. Now, what you see here is sort of like the scaffolding of a template. This is sort of the structure that you would find in a CloudFormation template in YAML format. Of course, you could create CloudFormation templates in JSON format, and actually I did that for many years and taught students the JSON format for many years. And then later, at some point in time, AWS also introduced YAML as an option for defining CloudFormation templates. And now I tend to teach students using the YAML format, but I'm equally conversant in both formats. And in both formats produce the same sort of code. They're interchangeable. Well, what you can see in this YAML document is a number of different sections. There's a AWS template format version section, description, metadata, parameters, and so on. All of these different sections can contain code which are used to define the resources that we want to deploy into AWS. Now, most of these sections are actually optional. You don't need to you're not required to include them in your template. You should have the AWS template format version at the very top of your template. And then the only section that's really required is the resources section, where you are defining the resources that you want to deploy. And you have to have at least one resource that you're defining in a CloudFormation template. All of these other sections are actually optional, although most of the time we'll include one or more of these optional sections when we create our CloudFormation templates. So let's walk through each one of these sections in more detail so you can understand what sort of capabilities these sections are providing in our CloudFormation template. Let's start with the parameters section. The parameters section of the CloudFormation template allows you to define input parameters that a person would provide when launching a CloudFormation stack. We can parameterize our stacks, and the benefit of that is that we can essentially dynamically inject some variable values into the stack at launch time. And that allows us to take a CloudFormation template and potentially create multiple stacks using a single template, with each stack potentially having a different set of parameters. You might have a stack that you create for a development environment, for example, and that development environment might have resources that are defined with a smaller amount of compute and memory capacity. You could use that same template then to launch a stack for a production environment, and via these parameters you could specify that the production stack has a significantly higher level of compute and memory capacity for the resources. So this is really the value of the parameter section. It's allowing us to parameterize and make our stacks somewhat dynamic. Now, when you define parameter values, you're essentially sort of defining variables within the stack, and each parameter has a logical name which must be unique within that template, which makes sense. It's kind of like creating variables. You would have unique variables that are mapped to individual values within your application. And the parameters that we define can have a number of different types. You can have string parameters and numbers. You can have a list parameter that's storing a set of string values. And then there are a few different AWS specific parameter types that you can take advantage of as well. There are a maximum number of parameters that you can specify in a template, up to 60. I've never gotten anywhere near that many parameters in a single template, so it's not really a limitation in my mind. When you specify parameters in a template, you can then reference the value of those parameters by using a special function that is called the ref function. And the shorthand way to call that function is by using the exclamation ref syntax. And I'll talk a little bit more about functions later. But any parameter that you define in your stack, you can also then reference the value of that parameter in some other location of the stack. That's really the value of parameters. And at the bottom here, you can see an example of defining the parameter section and the format. So you have the parameter section of the template. Each parameter has its own logical ID. You would specify the type of the parameter, and then there might be one or more parameter properties that you can set. And speaking of parameter properties, you can define a number of different sort of constraints for a particular parameter. For example, you can specify a list of values that are allowed values, and any value that's not within that list will not be accepted by CloudFormation. You can also define a default value. So if the person who's launching the CloudFormation stack, if they don't provide a value for a particular parameter, then CloudFormation would use the default value associated with that parameter. You can define a max length and min length, max value or minimum value. You can create sort of constraints for these parameter values within the template. There's also a special parameter property called no echo, where that's something you would commonly use for something like a secret, where if somebody's providing a parameter value, you don't want to echo out that value either to the screen or into CloudFormation logs. Here's an example of a parameter. This parameter is called instance type parameter. That's the logical name. And the parameter is a string parameter. So you see the type is string. It's got a default value. If a person doesn't provide a value for this input parameter, then CloudFormation will default to the t2.micro value for the parameter. It's also got a set of allowed values, T2 micro, T2 small, T2 medium. Whatever value is provided for this parameter must be one of the values in that list. And then there's also a description, which is always helpful to provide. That way, if somebody's trying to deploy a stack using this template, they have some idea what this parameter is for. You see lower down in the template in the resources section, and we'll talk about the resources section here a little bit later in the video, but in the resources section, you see that there is an EC2 instance being defined, instance resource, and one of the properties of that EC2 instance is a property called instance type. And the value of instance type is referencing the instance type parameter, meaning that whatever value we set for the instance type parameter will be used for that instance type property in the EC2 instance resource definition. Okay, we talked about input parameters. We can also output information from a CloudFormation stack using the outputs section. So it's the outputs section is kind of the opposite of the parameter section in the sense of parameters is allowing us to input parameter values into the CloudFormation stack. And the outputs section is describing what sort of values we want to output from the stack. When CloudFormation creates when CloudFormation creates the stack, it can then output a set of values associated with different resources that were created in the stack. An example is that if CloudFormation creates something like an S3 bucket, the CloudFormation stack output could return the actual name of the S3 bucket that was created. Similar to parameters, there are a maximum number of output values allowed, up to 60 outputs. Again, I've never worked with a template that output that many output values, so that's not really a big limitation. You can use a number of different values when outputting information from a CloudFormation stack. It could be a literal value. It could be a reference to a parameter like we saw in the previous example. It could be something called a pseudo parameter, which we'll talk about in a bit, or an intrinsic function, which we'll also talk about a bit later here in the video. We can also conditionally output values. For example, you might use the same template to deploy a development environment and a production environment. And there might be certain output values that you would want to output in a development environment that you wouldn't output in production, or vice versa. And that's certainly possible using conditionals. Here's the syntax of the output section. Each output has a logical ID, a description, and a value attribute. And here's an example of an outputs section. We have an output we're defining. Actually, we have two outputs we're defining here. One called backup load balancer DNS name with a description and a value. The value is using the get attribute function, which we'll learn about later. And it's also going to be conditionally output based upon a condition that we have defined. And then there's also an instance ID output, and its value is referencing a parameter value called EC2 instance. So that's the outputs section. I've mentioned functions a few times now, and CloudFormation provides us with a whole set of different intrinsic functions that we can leverage to help us accomplish certain things. For example, we can use conditional functions to conditionally create resources or conditionally define attribute values. Conditional functions kind of work like an if-then-else sort of programming statement. We can use conditionals, we can use intrinsic functions to look up values. Like you saw the the ref function allows us to reference the value of a parameter. We can also use intrinsic functions to retrieve data, potentially from other stacks. So there's lots of different uses for intrinsic functions. They're incredibly helpful in allowing us to build more complicated CloudFormation templates. Now, these intrinsic functions aren't available in everywhere within the template. We only use them within certain sections of our CloudFormation template, namely like the resource section is probably where you would find most of these intrinsic functions being used. You saw an example just a short while ago where we were using functions within the outputs section as well. Here's an example below where we're using an intrinsic function. There's a property called myLBDNS name, and we're using the get attribute function, the get at function, to retrieve an attribute value for a CloudFormation resource. Now, there are a bunch of different functions that are available. I'm not going to go through every single one of them, but I will share some of the more common functions that you would utilize in CloudFormation and that you'll probably come across in this class. There is now each function has kind of like a full definition name and then a shorthand way of referencing the function. And the shorthand way of referencing the function starts with an exclamation point. Now, I personally like to use the shorthand version, and that's what you will find in the examples in the class and any of the demo templates that I've built for you. But you could also use the full version of the function name version as well. There's a base 64 function. The shorthand version is exclamation base 64. And that allows us to take text and like a text string and convert it to what's called a base 64 representation. Now, the only reason that you would really use this within a CloudFormation template is if you are defining a script for something like EC2 user data. Remember, EC2 user data allows you to define a shell script which will be executed at launch time. And that shell script text actually needs to be provided to EC2 in base 64 format. And so this function allows you to do that properly. There's a find and map function, and I'll talk about maps here in a little bit, but essentially you can create a map data structure in CloudFormation and then leverage it to do some really interesting things and reference values using a hash kind of construct. The get at function or get attribute function allows you to reference the value of an attribute for a resource in the template. Most any sort of resource that you define in the template has a set of attributes associated with it that you can then reference from other resources in the template. The example here is referencing the DNS name that's associated with a load balancer. There's a getAzs function which will return a list of availability zones for the particular region in which you're deploying the CloudFormation template. The example here is is, well, we're actually hard coding the region, but it's getting a list of availability zones associated with US East 1. A few more. We have a join function that allows you to concatenate a set of string values into a single string. The values could be partitioned by an optional delimiter. Here's an example where we're joining three different characters, A, B, and C, with a colon delimiter, and that will return a string where all of those values have been concatenated and delimited using the colon character. We can use the select function to select a particular object from a list. In this example, we're selecting object 1 from the list, and object 1 returns grapes. And if first you might think this is a little confusing, but if you think back to software and application development, then you'll probably remember that most lists start with 0. So if I were to do a select 0, that would return apples. Therefore, select 1 would return grapes. The ref function I've talked about a few times, but that allows us to reference the value of a parameter or a resource in our CloudFormation template. It's something that we use all the time within our templates. And then there are a set of conditional functions we can also leverage. Things like an equals function or an if function. The equals function will compare two values and return true or false based on whether or not they're equal. And then there's a condition, an if function, where we can evaluate a particular condition, and if that condition is true, it will return one value, and if it's false, it will return a different value. And the example that I provided below that is saying if this condition is true, so if we are deploying this into a production environment, then use the M3X large value, otherwise use the T2 micro value. And that's a way of dynamically defining what kind of compute capacity to associate with something like an EC2 instance, depending on some sort of condition that's set. We can use pseudo parameters within our CloudFormation templates. A pseudo parameter is like a built-in variable that is automatically being provided to us by CloudFormation. We can reference these pseudo parameters in our template and gain some useful information from them. For example, there's an AWS account ID parameter, and that will return our AWS account ID for the account that the stack is being deployed into. There's a region parameter, which is really helpful, and that will return the region that the CloudFormation stack is being deployed into. And you might be asking yourself, well, why would the CloudFormation stack need to know what region it's being deployed into? And that's because we'll look at the mapping section here shortly, but we might want the CloudFormation stack to configure resources differently depending upon the region that the stack is being deployed into. And therefore, the CloudFormation stack needs to know what region it's running, it's being deployed, it's running resources in. So it can do that, and it can find that out using the AWS region pseudo parameter. I mentioned the mappings section here just a short while ago. The mapping section is a really helpful capability. It allows us to define a set of keys, and you could think of the keys as being sort of like variables. And these keys map to corresponding sets of named values. And one of the most common use cases for these mappings is to set certain values depending on different conditions, like the region that a template is in a stack is being deployed into. The way that this works is we have a mapping section, and within the mapping section we define a mapping ID, and that mapping ID is associated with one or more keys, each of which has its own key value. Best way to understand this is to look at an example of a mapping section. Here we have a mapping section called the region map. That's the logical name of the mapping. And the region map has two keys, US East 1 and US West 1. In each one of these keys has a set of keys. In this case, 32 and 64, each of which has a corresponding value associated with it. Now, what this mapping is doing is it's defining a set of AMIs that are available in each region. Because if you recall, AMIs are region specific. If I create an AMI, it's only going to be available, let's say, in US East 1. That same AMI will not be available in US West 1. If I wanted to make it available in both regions, I'd have to copy the AMI from US East 1 to US West 1. And once I copied it, the AMI ID would actually be different, because every AMI has a unique ID. So if I were to deploy a CloudFormation template, if I wanted to deploy the same CloudFormation template in US East 1 and US West 1, I would need to define a way to dynamically change the AMI for an EC2 instance based upon the region that I'm deploying that stack into. And I do that using a mapping. You can see in the example below, in the resources section, we're defining an EC2 instance called my EC2 instance. And one of the properties for that instance is the image ID. For the value of the image ID, we're referencing this map. So we're going to use the find in map function, and we're going to use the region map, and we're going to pass in a key, which in this case is actually a pseudo parameter, AWS region, which is going to be the current region that the stack is being deployed into. So if the stack is being deployed into US East 1, then the find and map function will look at the region map, and then the US East 1 key, and then finally the last key that's provided is 32. It'll look at the 32 key, and the find and map function will return that first AMI value, the AMI-6411E20D value. That's the value that will be provided. These maps are just incredibly useful in allowing us to dynamically deploy stacks in multiple regions, or multiple different sorts of situations. I oftentimes will use maps to define different environments. For example, I'll have like an environments map, and then I'll have like a dev environment, a test environment, a staging environment, a production environment, each one of which has its own set of keys associated with each of those environments. And then that way I can dynamically modify the different resource attributes and properties based upon the environment type that I'm using when I deploy the CloudFormation stack. The conditions section allows us to control the creation of resources or the definition of resources in our CloudFormation template. And the way that this works is we can define a condition in the template and then later on validate whether that condition is true or false. If the condition evaluates as true, then that means that a resource will get built. Here's an example of how we can define a condition in the condition section and then leverage it later on to conditionally build an AWS resource. Here you can see we have a parameter that we defined called env type, or which is shorthand for environment type, and that the environment type parameter can have one of two different values. It's either going to be prod or dev. In the conditions section, we're creating a condition called create prod resources. We're using the equals intrinsic function to determine if the environment type parameter that was passed in, if the environment type parameter value was prod, then the equals function will evaluate to true. And this condition, this create prod conditions condition will also evaluate to true. Later on in our resources section, we have a resource called mount point, and that mount point is creating an EC2 volume attachment. It will conditionally be created based upon the value of the create prod resources. If the environment type then is prod, the create prod resources condition will evaluate to true, and therefore the mount point resource will be created. If the environment type were dev, then CloudFormation would skip the creation of this mount point resource. It would not be created. Well, we've talked about many of the different sections that are available in the CloudFormation template, and all the sections I've talked about so far are optional sections. We finally come to the resources section, which is the one section which is not optional. It's required in our templates. And this is the most important section. This is where we actually define the AWS resources that are going to be built by the CloudFormation stack. And these resources are anything from IAM policies to VPCs and subnets and security groups to EC2 instances and elastic load balancers, databases. Everything that you might create as a resource is going to be defined in this CloudFormation resources section. Each resource has a logical ID and has a resource type and a set of properties. Now, the CloudFormation template is a declarative template, meaning that it doesn't really matter what order you define the CloudFormation resources. And that's really important to note. Let me say that again. The order in which you define CloudFormation resources does not matter, because what CloudFormation will do when it retrieves your template is it will evaluate the resources that you have defined in the template, and it will determine a plan for creating those resources. CloudFormation understands how to create those resources in the proper order. Most of the time, there are a few exceptions to that where we need to provide CloudFormation with some explicit guidance as to how to create CloudFormation resources, and we can use the depends on attribute to specify dependencies between different resources within a CloudFormation template. But that's relatively rare. Most of the time, we don't need to use a depends on attribute. Most of the time, CloudFormation is able to come up with a plan to create our resources in the proper order. In terms of each of our resources, I mentioned that each of one has a logical name, has a type, and then it has a set of properties. And there are all kinds of different ways that we can define these properties within the CloudFormation template. They could be strings, they could be numbers, they could be lists or Boolean values, true, false kind of values. They could be values that are derived from functions or things like parameter references. So many different ways to define these property values within our template. And you might be asking yourself the question, well, how do I know what properties to specify for any given CloudFormation resource? And the answer is that you really need to look at the documentation, because every single AWS resource has its own unique set of properties and expected values. And the only way to really understand those is to look at the documentation. Even though I've been using CloudFormation for many, many, many years and have built like literally hundreds of templates, I don't have all these properties memorized. And so when I'm building CloudFormation resources, I'm constantly looking at documentation. Here's an example of a resources section where we are defining two different resources. One is a resource called Web1, and that resource is an EC2 instance. It's using a couple different properties, a user data property. There you can see that there's a base 64 intrinsic function being used, and it's essentially setting an environment variable sort of value. There's an availability zone property which is being set, and an image ID property which is being set in the template. And then also a second a second resource called MyQ, which is an SQS queue. When we create CloudFormation stacks, generally we're defining all of the resources needed for the stack within one template. But it is possible to nest templates. In other words, we could create a stack based upon multiple templates. So you could have a kind of a parent template that is referencing child templates. And sometimes that's useful for segmenting different resources within a template. I personally don't use nested stacks all that often. I've created incredibly complex and very scalable application platforms in AWS, and have personally never found a need to use nested stacks, but it is a capability that is available to you. I wanted to say something about the configuration state and how configuration state is managed by CloudFormation. when you create a CloudFormation stack using a CloudFormation template, and when you launch a CloudFormation stack using that template, you may also provide a set of parameter values, because you might have certain resources whose properties are being dynamically determined at launch time. When CloudFormation creates that stack, it maintains some state. It maintains some configuration information about that stack. And that configuration information is stored in the CloudFormation service in your AWS account. And what's really valuable about that is that multiple people could be making changes to that CloudFormation stack, and the state of that stack is always stored in one place. Now, there are other infrastructure definition tools on the marketplace. Probably the most popular one is a tool called Terraform, which is developed by HashiCorp. I've used Terraform extensively as well. And one of the big differences between something like CloudFormation and Terraform is that Terraform stores your state in either a local file directory, or you can store the Terraform state in some other sort of hosted service. That Terraform state is not being stored by AWS. You basically have to figure out for yourself where to store the Terraform state information, which used to be really tricky to do, but now is much easier. And so that's one key difference between these particular tools. By the way, I get students and people in the industry asking me all the time, what's better, CloudFormation or Terraform? If you go out into the marketplace, I think you'll probably find, in general, more companies using Terraform as their infrastructure definition tool. And one of the benefits of Terraform is that it works across multiple cloud platforms. You can use the same tool to define resources in AWS as Azure or GCP, or dozens of other cloud platforms, and a lot of companies like it because of that cross cloud or cross platform capability. And I as I mentioned, I've used it extensively at a number of different organizations. And here's what I always tell people. If you are an AWS only shop, if your organization is building everything within AWS, then my perspective is that CloudFormation is clearly the superior solution. And there are a number of reasons for that. But in terms of its support from AWS, you get first-class support. CloudFormation is the tool that AWS itself uses to provision infrastructure, and so generally it's extremely reliable and scalable. And as soon as new features are available in an AWS, that support is baked into CloudFormation. Plus, CloudFormation is a service which is managed by AWS, and they're managing the state for CloudFormation stacks, which is very, very helpful. Terraform is also an excellent tool if I were an organization that had to manage multiple cloud environments at multiple cloud providers. Then I might take a closer look at Terraform. But in general, if I have to pick between the two, I will pick CloudFormation every day of the week. Well, let's wrap things up here in this video by just talking about a few of the best practices associated with CloudFormation. Now, when you're building CloudFormation templates, it's a best practice to store those templates in a version control system like Git. Again, we're using infrastructure as code practices, so we're building AWS resources and managing those resources like we manage and build our application code. In fact, we can even leverage continuous integration, continuous delivery pipelines to deploy our AWS infrastructure using CloudFormation. When I'm building CloudFormation templates, I rarely start from scratch. You could open up your code editor and start from literally a blank page, but generally I'm taking some sort of sample template or an existing template that I've created, and I'll use that as my starting point for building out a new template. And that goes into kind of segues into my next point, which is you want to try to reuse your CloudFormation templates as much as possible. Reusability is key, and that speaks to the design of the template itself. If you're building out like an application environment, you would generally want to create a single template that would describe how that application is going to be supported and deployed in a dev environment, a staged environment, a production environment. You would not want to create 3 different templates for each, representing each of those environments. You'd have a single template that you can use that has maybe input parameters and uses the mapping capabilities to dynamically determine the value of resource properties for each one of those environments. I mentioned that you can nest stacks. You really shouldn't nest stacks more than one level. If you do like multi-leveled stacks where you have like 3 different layers of nesting going on, then you're going to run into trouble. And you can ask me how I know that. I've made that mistake before. But you want to avoid that sort of complexity. And in my experiences, it's absolutely not necessary to do that level of nesting. You should judiciously use parameter values and use them to set your environments and to dynamically define resource property values based upon the regions. And so you never want to hard code values into your resource definitions. If you look at your CloudFormation template and you find that you're hard coding values for different properties into that template, then it generally is a pretty clear signal that you need to take a step back and parameterize those values using the CloudFormation parameters. Remember to add tags to the resources that you create. That's really important. Tags are super helpful, especially at a larger scale, in terms of helping you to organize and find different resources. And then when you're creating CloudFormation resources, especially things like database resources, you can define what will happen when that stack is deleted. So you can use CloudFormation, of course, to create a stack of resources, and then if you delete that stack, CloudFormation will automatically delete all of the different resources associated with that stack, and that might be undesirable in certain circumstances. For example, if you have like a database, you might want CloudFormation to create a final database backup or snapshot before that database resource is deleted. And so that's something that you can define in your CloudFormation template.